Good morning, class. So, this week, we're going to continue our work with trigonometric equations. Now, so far, we've only been working with rather simple trigonometric equations, right? As a form of review, let's just see what we've been able to do so far. We've been able to solve these kinds of equations where we have signs or trigonometric equations on either side of the equation, and then find the different radians, right, for the values of x. Nothing too complicated or complex. Then we were able to solve equations where our x had a coefficient, right? Remember, we solved a couple of those. And we also were able to work with having, on the other side of the equation, any number that wasn't in the periodic table, remember? From April 1st's work. But, even if it has been a bit complicated, we've stayed pretty simple. So this week, we're going to begin working with a bit more complex. Okay, we're going to work with the very dear trigonometric identities, all right? I know you guys don't love them, but I'll try to make it as easy as possible. So before we can dive through trigonometric identities, we have to first learn how to solve trigonometric equations in quadratic form. All right, so that is what this video is going to be about. All right, so let's just dive right in. We have our first example. 4 sine square of x minus 1 is equal to 0. All right, now, normally we don't have a square on our trigonometric equation. That's why this one is going to be different. So how do we solve this? Well, our approach remains the same. We always want to have our trigonometric equation alone in one side of the equation. All right? So we're not going to use the unit circle to find 0 because we don't care about 0. What we want to do first is leave this sign alone. And how do we accomplish that? Well, first step, we take the 1, move it to the other side. Used to be negative, now it's positive, right? And then we got to take the coefficient of the sign and remove it. How do we remove it? Well, by dividing by 4. Right? We divide by 4, and what we're left with is sine squared of x is equal to 1/4. And this is the point where we're supposed to use the unit circle and find the number, or at least that used to be it. And I know what you're thinking, pero Mistel, en el círculo unitario no hay un cuarto? And you are right. Let's bring up our unit circle. Right? There is no 1/4 in any point. There's 1/2 though. All right? And why is that? Well, because our equation isn't telling us to find the sine of x. Isn't telling us that the sine of x is 1/4, but rather that the squared of the sine of x is 1/4. So how do we go from 1/4 to 1/2? Well, here's the answer. You take the square root on both sides of the equation. Right? So the square root of sine of x would be, the square root of sine squared of x would be sine of x. And the square root of 1/4, well, the way we do this is the square root of 1 is 1, and the square root of 4 is 2. So it's telling us that sine of x must be equal to 1/2. But, very important guys, it's not only going to be the positive 1/2, but also the negative 1/2. Alright? Remember, whenever we include a square root, we have to take into consideration both the positive solution and the negative solution. Right? So positive 1/2 and negative 1/2. Those are our possible solutions, or at least for the unit circle. So now we go back to our unit circle. So where is our 1/2? Well, remember, sine is the y coordinate. So here we have one. Positive 1/2 belongs to 30 degrees, but it also belongs to 150 degrees. So the angles that yield positive 1/2 are going to be 30 and 150. But like I said, because we included the negative 1/2, we also include 210 and 330. In other words, the solution for our x would be all the values or the coterminal angles of 30 from 0 all the way up to 360 degrees. All right, so once again, it would be 30, 150, 210, and 330. And the last step would be to change them into radians, and that's what was done here, sort of. They just give it directly in radians, but that's the exact same principle. So we have a total of 4 solutions, possible solutions rather. All right, and here they are. Pi divided by 6, which is 30. 5 pi divided by 6, which is, I forgot, 150? I think so, yeah, 150. And then we have 7 pi 6, which is 210. And finally, 11 pi over 6, which is 330 degrees. All right? So that is what you're going to be doing with this quadratic equations. I hope you have a nice day, and I'll talk to you guys later.